Welcome to my video on the topics of algebra in mathematics. Before we go into the details of various topics in algebra, first of all, I will briefly explain what is algebra and learn about the fundamental concept of it. After that, we will then talk about the 10 main topics under algebra that usually appear in your high school math curriculum and of course in your math examination. And also, if you like my videos, don't forget to subscribe to my channel and like my video. So, in high school mathematics, there are 5 main topics. The first one is geometry. Geometry is actually a branch of mathematics that studies the sizes, right? Shapes, position, angle, coordinates, or the dimension of things. In two-dimensional space, we talk about the flat shapes like the square, the circle, or triangle, etc. So in the two-dimensional space, you see that we have the length, we have the width, and then we calculate the areas of the square, or area of the circle, or area of the triangle. This is the two-dimensional geometry. And we also study the angle. Say, for example, given 2 lines here in a triangle, given the information of the length of here, we calculate the angle by way of the concepts called trigonometric function. And in addition to two-dimensional space, when it comes to 3D, we have the third dimension, which are the heights or depth. That's why we study the sphere, the cube. Say, for example, we have the cube like this. In the 3-dimensional space, because we not only have the length and then width, we also have the height or even the depth. That's why you can calculate the volume of the cube or the volume of a sphere. So this is about the key topics in the geometry. In addition to that, in the advanced mathematics, where we will study in the 3-dimensional coordinate plane, we have an x, we have a y. We also got the vertical one, which is in the 3-dimensional space. We will study the points or the factors in the 3-dimensional coordinate geometry. The next one is the calculus. Calculus is a mathematical study of the continuous change, just like the differential calculus and integral calculus. That's why you also come across the terms for differentiation, integration for the topics calculus. Put simply, differentiation is about, say for example, in the xy coordinate, you are given a quadratic function. The question is asking you to calculate the slope of the straight line tangent to the quadratic function at this point. So by way of differentiation here, we can simply take the derivative of the point here to calculate the slope of the straight line here. And this is the key features of the differentiation or the differential calculus. For integration, it is a very important topic in the calculus. The key features of the integration is like we have again in the xy coordinate plane. The aim is to calculate, say for example, we are given a function called y equal to fx. The objective is to calculate the area below the curve and between the x-axis. So by way of the integration, we can find out the area under the curve. So put simply, integration or integral calculus is concerned about the accumulation of quantity, or you say the areas under or between the curves. Differential calculus here is about the rates of change or slope of the curves. But we will talk about many details regarding the calculus in the later videos. The next topic is about statistics. Statistics is actually a mathematical body of science that pertains to the collection, analysis, interpretation and explanation or presentation of data. Because in most circumstances, it is where that we will collect or we can collect the whole population of data to do the analysis. When the whole census or population of data is not really available, then we will use a sample of data draw from the whole population of data in order to analyze or make inference or even make prediction based on the sample data. So in statistics, when we are doing the sampling, we will have the result like this. Now we have a y-axis and here is the x-axis. Usually the data will follow the distribution like this. That means x can take on different values. For x take on this value, the y will be corresponding the peak of this distribution. Here the y is talking about the frequency of the value taken for value of x. Or you say how many times the sample x equal to a, say for example, will occur in a sampling. And this is the key description of the statistics. And then the next key topics in mathematics is the probability. Probability is another branch of mathematics concerning the numerical description of how likely an event is to occur, or the probability of an event, which is the number between 0 and 1. Say for example, we have an event which is rolling a dice, and then what is the chance or what is the probability of getting the value of 4? Obviously, a very simple case, the probability is 1/6. And this is what we call the P probability of the event equal to 1/6. And then the value of the probabilities will be always between 1 and 0. This is PE. And this is the very simple features of the probabilities. And now it comes to the topics of algebra. So algebra is actually a branch of mathematics dealing with symbols and also the rules for manipulating those symbols. Say for example, now we have a very simple expression which is like 2, 1 to the power 2, and then plus 3, 1, and then minus 1. And then immediately you can calculate the value of this expression to be equal to 4. And then now you want to replace the value of 1 by a value of 2. Say for example, we have the expression here. So the result of this expression immediately you can calculate, which is equal to 13, right? Now, this is a key part of the algebra. Now we want to replace the fixed value 1 and 2 by a symbol called x. So now we have the expression like this: 2x to the power 2 plus 3x minus 1. And then on the left hand side, we have the variables y to replace the fixed value 4 or 13. So in this expression, we call it quadratic function, but actually it is the algebraic expression talking about the relationship between x and y. And this is algebra because we are not using the fixed value 1 or 2, but using an x or using the y to represent the output. So in this formula or in this expression, immediately you can see the relationship between x and y, because x can take on not only 1 or 2, but also take on different real values, say for example 100, can take on 1.1, say for example. And then this expression, given the values of x inputted into the expression, will give you one and only one output under value of y. This is the concept of function, and this is also the key part of the algebra. Because when you look at the previous two simple expressions, it's just expressed in terms of the fixed value. You can easily calculate the result, but you cannot know the relationship between x and y. But now with this expression, you can now understand the relationship between the input variable x and then the output variable of y. And then this is also called the quadratic function. In addition to quadratic function, we also have many different types of function. One of the very simple example is the linear function, which is something like this. Ax. X is the input, y is the output, and then a is just the constant. So actually, by expressing the variable in a formula, in an expression, actually it can have a lot of application in the real world example. Say for example, y can be can represent the price of your apartment or your properties, and then x can represent the size of your apartment. And then with this expression, it's actually link up the input variable, which is the size of your apartment, and then the output, which is the price of your apartment. And then the constant here can be the price per square meter. X can be certain square meter, and then y can be the price of your apartment. So go back to our previous example about the quadratic function here, or the algebraic expression. So the first key features, as we have explained before, is about the relationship expressly represented by a formula here. So obviously, in this function, x can take on different values and give out corresponding values for y. But now, it comes to the second features of the algebra. In this case, rather than setting the values for x, we set the value for y. Say for example, we want to set the value of y to be equal to 0. It can be 1 or 2 or the other values, but for simple, we express this y is equal to 0. So under this expression, now we have on the left hand side we have 0, and then on the right hand side we have a 2x, the same as before, plus 3x minus 1. So the key application or key features of the algebra is to find the value of x so that the result is equal to 0. So in other words, we're saying that we want to find the root of this equation. Because previously we have the y here, we call it function, because we given the value of x and then give the value of y as output. But now we set the output here to be equal to 0. That's why we want to find the root of this equation. Not function, is equation. So this is one of the very typical example of the quadratic equation. So to solve this equation, simply we have the methods. We know the root is expressed by the minus b, by this generic formula, b squared minus 4ac and over 2a. Assuming that we are assuming a general expressions of the quadratic equation, like 0 equal to ax plus bx plus c. So if you have the values for the corresponding constant a, b, c, then immediately by way of this formula, you can calculate the roots of the equation. So let's summarize the key features of the algebra. We use the variable x to replace the fixed values, and then represent the relationship between the x variable and y variable in a function or expression. And sometimes we'll the other second feature is to ask you to find out the corresponding the roots of the equation by setting the value of y to a certain value. And this is the common features of the algebra. In fact, algebra is a pretty broad subject in mathematics. In my math videos, I will talk about the 10 main topics in algebra, which I believe these topics are very important and essential for you to learn and build up a strong foundation so that you can progress to study more advanced math topics in the future. So in the first chapter, in the next video, we will talk about functions. As we have previously mentioned about the linear function, the quadratic function, the function represents the relationship between the x variable and then the y variable. X is the input variables, and then y is the output variable. And so in the first chapter, I will go through with you the fundamental principles of function. What is the key features? What is the fundamental principle of it? And I'll also give you an overview of different types of functions like linear function, quadratic function, trigonometric functions, exponential functions, and logarithmic function. You will definitely come across these functions very often in your math class. We not only study the algebraic expression of the function, we also will study the graphical representation of the function so that you can visualize the relationship between x and y variable in the coordinate plane. So that's why in my later videos, for chapter 2 and 5, we will go into the details of each of the functions and we'll study in detail the linear function and equation. Just like this form, the standard format of the linear function. This is the constant, x is the input variable. So here is the function. If you set the value of y to certain real value, then it becomes the equation to solve the equation. And we'll study the linear function here. And then secondary, in the next chapter, we'll study quadratic function, which is usually expressed in terms of this expression. This is quadratic because the power here actually, you see, to the power 2. X here is actually to the power 1. That's why it's actually is a function to the degree of 2. This is to the degree of 1. And then in addition to that, we'll also talk about the graphical representation of a straight line. Just like in the xy coordinate plane, we'll study about the equation actually that can be expressed in the graph like this. And then quadratic function, we have the graph should be some shape of parabola. Next, in the next chapter on the trigonometric function, we'll talk about the function like y equal to sine x or cosine x, or the last type, which is the tangent x. The x here is not a real value but an angle. The trigonometric function will take on the angle and output the corresponding value. And then in the last types of function, which is about the exponential function and also the logarithmic function. The shape of the function will be very different from the linear function or quadratic function. The shape will be something like this. The straight line actually pass through the point here, which is 0, and then y equal to 1, and then the equation or the function of the graph is something like this. X is the variable, input variable, a is the constant. So different value of a, either a greater than 1 or a less than 1 or greater than 0 will have different shape of the graph in the xy coordinate plane. So we will go into details of the exponential function and logarithmic function later. So in the later videos, we'll also talk about polynomial. So in the previous chapter, we talked about linear function, quadratic function. In polynomial, usually it is expressed in the format like this: x to the power 3 plus 2x to the power 2 minus x minus 4, say for example. Because why it is called polynomial? Because it is actually to the power, the largest degree of the polynomial is up to 3. So we call it polynomial. So in this chapter, we will talk about the polynomial, and we will talk about how to find the corresponding factors for these polynomials with the method called factorization. So usually we can express the expression in different ways for polynomial. We can express the polynomial like x minus a or x minus b and x minus c. So we try to factorize the expression here into each of the brackets. So each of the bracket we call it factor. So we will learn the methods. How can we do this? And also we will learn about the concept called division algorithm to perform not the division of numbers, but the division of polynomials. And then after that, we'll talk about the next topic, which is the search, rationalization, and number system. The search is actually means something like that, the root 2 and then a root 3, something like that. Rationalization is about moving the radicals. This is called radical and also called the surd. They are the same name. So sometimes we will encounter certain expression like this, root 2 minus root 3. So rationalization, the topics here, is about moving the surd or radical from the denominator to the numerator, so that we can find a way to handle the expression of fractions more easily. And then we will discuss some of the very basic topics like formulae, rate, ratio, variation, percentage, etc. Then we will go into the next chapter, which is the very interesting topics called sequences. Sequences is about the collection of terms in a sequence. In the video, we will study two common sequences, which are arithmetic sequence and also geometric sequence. So for arithmetic sequence, it is about a collection of terms like this. The first term is a constant a, and then the second term is a plus d, and then the third term is a plus 2d, and then etc. up to the nth term, which is a plus n minus 1 multiplied by d. So obviously we look at one of the features of this sequence that each of the terms actually, when you take the difference from the term here and then this previous terms here, the difference is always equal to d, which is the common difference. This is the key features of the AS, arithmetic sequence. Similarly, if you take the difference between the nth term and also the n minus term, the difference is also always d, a constant d. So in addition to learn about the sequence here, we learn about the summation of all the terms in the sequence by an expression, which is a standard expression. Similarly for GS we call geometric sequence. So one of the key features of a geometric sequence is as follows. We have a first term a, and then we have second term a multiplied by r, and then we have third term which is a r to the power 2, and then up to the nth term we have a r to the power n minus 1. So be careful, it is not to the power n, it's n to the power n minus 1, because the first term we don't have any common ratio. This one is called common ratio. And then the second term we have to the power 1. So that's why, when up to the nth term, it is n minus 1. So one of the key features of the GS, geometric sequence, is that when you take the ratio of the terms here with the previous term, like AR divided by AR, the value will be always equal to R, which is called the common ratio. So these are two very common sequence that we need to learn to tackle our examination. So the last topic is about inequalities and linear programming. So in the chapter of linear functions, we learn about linear function like this, y equal to 3x plus 2, say for example. And then for inequalities, we will change the equal sign here to either greater than or equal to 3x plus 2 or less than or equal to 3x plus 2. So in a graphical representation, we have an xy coordinate, and usually a straight line is expressed like this. Y equal to, say for example, ax plus c. So now inequality, we will change the equal sign, as we mentioned, to something like this, greater than or equal to this expression. So for inequality, in terms of the graphical representation, it will represent the area, total area, above this line. This is the solution for these inequalities. And then after we learn about the inequalities, we will proceed to learn about the topic is called linear programming. Linear programming is actually about under a set of inequalities, which are consider them as the constraint. Say for example, we have y equal to a1x plus b1, or y equal to a2x plus b2, and then these formula say y is greater than or equal to, or y less than or equal to, and then this represents a constraint. From graphical representation perspective, we have the expression like we have a straight line here, inequality, and also straight line here, inequalities. So the common region or the feasible solution is the overlapping areas. Okay, so linear programming is about under sets of inequalities which are considered them as the constraint to the linear programming problems. We want to find a value for x and y, any values under this feasible region as confined by the inequalities, so that we can attain the maximum or minimum of a linear programming problems, which is usually denoted by LXY. We want to find a value xy from this region that maximize or minimize the problem here. So that's all about the introduction to algebra. In the next video, we will start our first chapter, functions and graph. Please stay tuned and hope you enjoy the lesson.